This is example 3 from section 4.2 in calculus class. We are studying optimization. Before we begin, there were a couple of mistakes in the problem. Number 1, I forgot to draw the picture for you. So I said that the fencing would make 2 side-by-side enclosures as shown, and I forgot to show that. So if you'll draw that picture. Also, your handout said, what is the maximum ARE? I forgot to write area, so if you'll fix that, please. Okay, I want you to read the question and underline anything that has to do with what is being maximized or minimized. Suppose you had 102 meters of fencing to make 2 side-by-side enclosures. What is the maximum area that you could enclose? So when it asks what is being maximized or minimized, we know we're maximizing something. And this says that we're maximizing area. So we are maximizing the area of what? The enclosure. Okay. Well, can we come up with an equation for that? Well, let's think about area. We have area of many different types of shapes. Overall, this enclosure is a giant rectangle. So the equation area equals length times width. We know that that's the area, how to calculate the area of a rectangle. All right, so we've finished with that portion of this problem. What are our constraints? Do we need to draw a picture? Well, we've drawn a picture. And in that picture, though, we should probably label some things. I know that I have length and width, but because we're dividing it into 2 enclosures, we have 2 lengths in each part. I'm going to call both of those X, and I know these would be equivalent, and then the widths I'll label as Y. Okay. So what are my constraints? Suppose you had 102 meters of fencing to make these 2 side-by-side enclosures. Okay, well, our constraints are there are only 102 meters of fencing. So there are So how could we write an equation using 102 meters of fencing? Let's look back at our figure. Every black line you see up here represents part of that 102 meters of fencing. So to write my equation, I have 1, 2, 3, 4 X's. I have 1, 2, 3 Y's. And together, or their sum, will equal 102 meters of fencing. So I have my equation to be maximized, and I have my equation of constraints. Let's solve the constraint equation for Y. We could solve for X. I'm going to choose to solve for Y. So pause the screencast and solve for Y, please. All right, so our equation, Y equals 34 minus 4/3 X. Again, you could have solved for X if you'd wanted to. Now we will use the constraint equation to rewrite the max-min function in terms of one variable, and then we'll simplify it. So our equation is area equals length times width. So area is equal to, let's go back up and look at our figure. Our length is equal to 2 X's. X plus X is 2X. So our entire length is 2X and our width is 1Y. So our length is 2X times Y. Remember, we've got to write our equation for area in terms of X and Y. Now we can make the substitutions that we need to. So area is equal to 2X times 34 minus 4/3 X. Let's go ahead and I'd like you to pause the screencast and distribute 2x to simplify this equation. Now we will find the critical points. Remember, critical points are the zeros of the first derivative. So let's find the first derivative of our function a. The derivative of 68x is 68 minus the derivative of 8/3 x squared is 16/3 x. Once you have that equation, recall to find the critical points, you set the equation equal to 0 and solve for x. And if we solve this for x, we get x equals 51/4, which is approximately 12.7, not approximately, it is 12.75 meters. All right, remember that we are maximizing, so let's make sure that this point is a maximum. So 12.75. I'll plug 0 back into the first derivative. If I plug 0 in here, I get 68 minus 0 is a positive. And if I plug 100 into the right-hand side, I get 1600 divided by 3, so 68 minus that gives me a negative. So the function is increasing and then decreasing, therefore I do have a maximum. So my x-coordinate is 12.75, and let's see what the problem asked us to find. It said, what is the maximum area that you could enclose? So I'm going to take 12.75 and go back to my equation for area. If I come back here, I can plug in 12.75 and calculate the area immediately. If I choose, however, to find y first, I can find y first, then plug x and y back into that equation. I'm going to go directly to the area. So my area is equal to, I'll use the equation where I've already distributed, 68 times 12.75 minus 8/3 times 12.75 squared. And so the maximum area is 433.5 meters squared.